Rain drips in silver threads from the high canopy. A single leaf trembles under the weight of something small. So small it almost isn't there at all. The sunlight catches it just right, revealing a faint outline. Delicate limbs, a skeleton traced in the palest green. The rest is nearly invisible, blending with the wet translucence of the leaf's skin. At this moment, it is neither shadow nor light, just a whisper of life suspended in stillness. Somewhere inside, a heart is beating, yet the red warmth of blood is gone from view. Hidden, vanished. For the predators scanning the leaves from below, there is nothing here to see. Just another flicker of green in a forest, made entirely of it. Deep in Central and South America's rainforests, the high canopy is a place of risk and reward. Here, predators watch for the slightest twitch, the faintest ripple of motion. For a small amphibian, to be seen is often to be eaten. Many species hide through color, through patterns, through sheer stillness. But this one carries camouflage to the molecular level. Its skin is already translucent, revealing bone and muscle in the right light. And yet, when it rests, the transparency becomes complete, an almost perfect vanishing act. Scientists studying amphibian camouflage have documented many survival strategies, but few match this in elegance or precision. This is the rainforest glass frog, and its disappearance is not just skin deep. It is written into its very blood. The glass frog's natural state is partial transparency, its pale green body mottled enough to blend with leaves in the dappled light. But during sleep, something extraordinary happens. As night fades into day and the frog settles under a leaf, most of its red blood cells, those carriers of oxygen and life, are shuttled away into the liver. There, hidden inside tiny blood-filled sacs, the cells are stored out of sight. To a watching predator, the frog becomes almost featureless, a pale phantom merging perfectly with its resting place. But the phenomenon raises a paradox. Blood is not just color, it is function. Remove it from circulation, and the body's tissues are starved of oxygen. In humans and most other animals, this would lead to rapid damage or death. In the glass frog, it leads only to invisibility. The scale of the transformation is staggering. Studies using high-resolution imaging have shown that during rest, up to 90% of the frog's red blood cells are packed into the liver. The effect is so complete that the organs, muscles, and bones seem to float inside a clear, green-tinged silhouette. And yet, the frog remains alive, its heart still pumping, its metabolism still functioning. For scientists, this is the unsolved puzzle at the center of the story. How does the glass frog store its life's blood without succumbing to oxygen loss or dangerous clotting? In mammals, trapping blood cells in one place would trigger immune responses or clot formation within minutes. Here, nothing of the sort happens. The animal rests in perfect stillness, as if suspended between life and absence. Several hypotheses have emerged from the handful of studies on this adaptation. One possibility is that the frog's tissues can temporarily operate on drastically reduced oxygen, perhaps aided by a lower metabolic rate during rest. This would allow it to function without constant circulation, relying on stored oxygen in tissues and plasma. Another theory suggests that the frog's blood chemistry is uniquely adapted to prevent clotting under these conditions, an anticoagulant mechanism unlike anything seen in mammals. Some researchers speculate that the liver itself plays a dual role, both concealing the blood and acting as a temporary oxygen reservoir, slowly releasing it back into the system as needed. Still, none of these explanations fully account for the speed and completeness of the change. The exact trigger for the blood shift, whether purely neural, hormonal, or a combination, remains unknown. Adding to the mystery is the fact that this adaptation appears only during rest. When the frog is active or threatened, the blood returns to full circulation almost instantly, flushing the skin with a faint red tint beneath its green hue. This rapid reversal suggests a finely tuned system, one capable of switching between near invisibility and full function in moments. For predators, that split-second difference could be the boundary between a successful strike and an empty leap. For the frog, it is the difference between life and death. The discovery of this blood-hiding adaptation has implications beyond the forest canopy. If scientists could understand how the glass frog prevents clotting during such extreme sequestration, it might inform new approaches to treating human conditions involving blood flow, clot risk, or oxygen deprivation. But the path to that understanding is steep. The frog offers no clues willingly, its secrets kept in the quiet hours beneath the leaves. Each attempt to study it risks breaking the very conditions under which the phenomenon occurs. In the end, what remains is the image, a leaf trembling in rain, a faint outline where a body should be, bones ghosting through a green haze. Somewhere inside, the blood waits in silent storage, unseen yet essential. In a world where most life survives by standing out, this creature endures by erasing itself from view. It is camouflage taken to its final limit, a vanishing so complete it borders on the impossible. And so the question lingers, as it has since the first researchers witnessed it. How do you hide your life's blood and keep living? The rainforest glass frog offers no answer, only the proof that it can be done.